Welcome back, everyone, and let's take a look at your review packet for Chapter 5. This runs through everything that we covered in Chapter 5. So we're going to start with the first question here, which goes all the way back to 5.1. So here it says the data shows the relationship between the number of hours studied and the score on the ACT exam for 10 students here at Hopkins High School. So question A asks you to enter this data into your list. So what I'm going to do is I'm going to enter in time studied into list 1. I'm going to go to my stat. I'm going to go to edit. I have a lot of different things in here, so I'm going to just kind of scroll over to list 1 and list 2. So let's clear those out. Remember to clear them out. Hit clear. Okay. If you mess things up, remember you can always go to stat and hit do setup editor. If you hit enter there, and you go back to stat, enter here, your list should reappear. So let's go ahead and start typing those values in. 0, 1, 2, 3, 4, 5, 6, 7, 8. Whoops, that's funny. I'm thinking it was 1, 2, 3, 0, 1, 2, 3, 4. Sorry. And then I go 4, 6, 7, 9, and 12. Do the second list. So let's see the score. 12, 15, 19, 21, 22, 24, 26, 29, 31. Oops. Love it when it does that. 29, 30, 26, 29, 31, and 35. Doesn't like to take my enter once in a while. All right, I'm just going to take a second and just double check, make sure all my points are listed in there correctly, because if they're not, unfortunately, things get messed up. All right, so it says run a linear regression equation. All right, so to run our linear regression equation, we go stat, right arrow, number 4. So I can go stat, sorry, not number 4, number 8. We've been doing number 8. Sorry, stat, right arrow, number 8. Make sure it says it on list 1 and list 2. Go ahead and hit calculate. And this gives me my slope and y-intercept. So it says write the equation below. Fortunately, it doesn't tell you how many decimal places. Let's go 3. 14.427. My slope is positive, 1.869x. So I got the linear one. It says using the same data now in part B, run an exponential regression equation. So find the exponential, same menu, stat, right arrow, but it's 0. So I go stat, right arrow, 0, exponential reg, I'm going to calculate that out. There I get my equation. So remember it's in the form y equals a times b to the x. So a is 15.027 times my b is 1.086 to the x power. All right, so now question C says, use both equations to predict a student's score who studied 6 hours. So what we're going to do is this is the x value, and we want y. So I'll plug them into both equations. So in the linear equation, I'd be going 14.427 plus 1.869 times 6 hours. So just got to type that in. So 14.427 plus 1.869 times 6. So the predicted score would be, and technically this would be y, these should be y hats, okay, would be 25.641. Do the same thing for the exponential. Oh, yep. So I thought I did in the wrong one there for a second, but I did. Whew, I got nervous there. So now I'm replacing the x with 6. So 15.027 times 1.086 raised to the 6th power. So this one predicts it at 24.652. I like the linear prediction better than the exponential. It's at least 1 point higher. All right, so number 1 came from 5.1. All right, number 2 is all the stuff we learned in 5.2 part 1 and 2. So we just got to remember our rules here. So like on the first one, remember multiplying, we add exponents. So the first two examples here, we're just simply adding the exponents. When we divide, we subtract. So 9 minus 4 is 5. 4 minus 5 is negative 1. Remember, if it's negative, it goes in the bottom. So if I went 5 minus 4, it would be 1, goes in the bigger. So now, when we have numbers, we deal with the numbers too. 12 divided by 6, well, that's 2. So I got a 2 in the top. 7 minus 3 is 4, so I have x to the 4th in the bottom since the 7 is bigger. 8 goes into 24 nicely 3 times. 3 minus 2 is 1, so it's just y over 3. Made that a little bit big, don't need that. All right, power to a power, we multiply the exponents. So x to the 35th, x to the 44th. Okay. Now, here we have to distribute and multiply. So I'm going 3 to the 5th power. Wow, big number. 3 to the 5th power, 243. And then I go 4 to the 5th power. 4 times 5 is 20, x to the 20th. So 7, do the next one, distribute. So 7 squared, 49. X to the 3rd being squared is x to the 6th. Y to the 1st being squared, y squared. All right, the last two on this page, anything to the 0 power is 1. So that makes those two 1. All right, I'm going to move to the second page, continuing the process. Remember, negative exponent causes it to go or go into the denominator and become positive. So 3 squared ends up being 9. So like when I do this one, I would actually go 1 over 2x in parentheses to the positive 3rd power. So now I have 1 over 2 to the 3rd power is 8x cubed. Negative exponents. Here, I'll put a little box around them. All right, next one. We distribute the exponents. So we get x to the 3rd, 6 to the 3rd power. There's a number we haven't done before. 6 to the 3rd power, 216. All right, 2 to the 4th power, if you trust me on that, is 16. X to the 4th, 5 to the 4th power. We haven't done that one, I don't think. 625. All right, next ones. Keep on plugging away. Wow, a lot of questions here. All right, 4 to the 4th power. Well, we haven't done that. 4 to the 4th power, 256. X squared raised to the 4th, multiply the exponents. 5 times 4, y to the 20th. Wow, 6 to the 5th power. So I'm just kind of plugging away. Sorry if I'm going a little too fast. So we have 7,776. Now we multiply the exponents. X to the 25th. 7 times 5, y to the 35th. All right, next one. I have to first flip the fraction and make it positive. Now I can distribute the exponents. Power to a power means we multiply. Y to the 21st over y to the 15th. Same thing, flip. So 3y to the 3rd over 2x to the 4th. Now I'll make it to the 5th power. So now 3 to the 5th power is 243. I think we've done that. Y to the 3 times 5, 15. 2 to the 5th power is 32. 4 times 5, that's been kind of a common one we've been doing. I think I did 22 or 3 times. All right, sorry I didn't box this one. Okay. All right, one last row of these. So if they have the same bases, the exponents are equal. So that makes those two really easy. Ooh, so 4 to the 5th power. Okay, that's 1,024. So I got to think about, and here's kind of a tricky way I could do this. Isn't 4 like saying 2 squared? So now I'm raising that to the 5th power. So that's like saying 2 to the 10th power. Whoops. This should be written as x, not 2. Okay, so now that they have the same bases, x equals 10. So if I think about this, 27 is like saying 3 to the 3rd power. So 3x, 3 to the 12th, so x equals 12. Sweet. All right, let's keep on powering on. So let's take a look at number 3. So all of those problems we just did were for 5.2 part 1 and part 2. The next page here deals with problems dealing with 5.3 and 5.4. This is where we change the radical to a fractional exponent and raise it to the power of the reciprocal. So to start this first one, I'm going to go x to the 7/6 power equals 12. So now I'm going to raise it to the 6/7 power, so raise it to the reciprocal. So I go 12 raised to the 6 divided by 7 power, 8 point, so I'm going to go out 3 decimal places, 8.414. Do the second one. I'm going to kind of do it in multi-steps. 3/5 power. I'm also going to add 14 to both sides just to save myself a little bit of time here. So I have x to the 3/5 power equals, those cross out, whoops, got to make that 14, Mr. Bartz, equals 30. So now I raise it to the 5/3 power. So x equals 30 raised to the 5 divided by 3 power. So 289.647. Okay. So I might try to do 2 steps here. I'm going to subtract 7. So I'm going to have 3, going to change this to the 3/4 power equals subtract 24. Okay. Now I'm going to divide by 3. So x to the 3/4 power equals 8. Raise it to the 4/3 power. So x equals, so 8 raised to the 4 divided by 3 power equals 16. I got a nice number. It does happen from time to time. All right, next one. Woo! Subtract 15. So 5, I'm going to rewrite this to the 7/3 power equals 25. Divide by 5. So x to the 7/3 power equals 5. Now I'm going to raise this to the 3/7 power. So x equals 5 raised to the 3 divided by 7 power, 1.993. All right, the next ones, I don't have to change the radical anymore. So like this one, I can just go right to the 1 reciprocal power. So x equals 100, raised to the 1 divided by 7 power. So x equals 1.931. All right, the next one. Divide both sides by 3. So x to the 6/7 power equals 8. So now, raise to the reciprocal of 6/7, which is 7/6. So x equals 8 raised to the 7 divided by 6 power, 11.314. All right, continuing on, I'm going to move this up just a little bit just to make life a little bit easier. So, we'll subtract 8. So 4x to the 4/9 equals 64. Divide both sides by 4. So x to the 4/9 equals 16. So now I'm going to raise it to the 9/4 power. So x equals, so 16 raised to the 9 divided by 4 power should be 512. Another nice number. Sweet. All right, this one, still kind of getting the same process. Move the number to the other side. So 6x to the 3/5 equals 24. Divide both sides by 6. So x to the 3/5 power equals 4. So raise it to the 5/3 power. So x equals 4 raised to the 5 divided by 3 power, 10.079. All right, last one here. Whoa, wrong color, sorry. So subtract 10. So 7x to the 2/3 power equals 63. Divide by 7. X to the 2/3 power equals 9. So now I want to raise it to the 3/2 power. X equals 9 raised to the 3 divided by 2 power, 27. All right, just like that, 2 pages of the review done. Let's go to the last page. Well, if it will flip over. All right, so here it just says, write the following logarithms in exponential form. So all you have to do is write it in exponential form. So base 2, exponent is 7, equals 128. Notice how it makes a true mathematical statement. It's kind of a nice way you can check. So this one, 6 is the base, exponent is 4, number 1296. Base 3, exponent is 5, equals 243. Hopefully those were pretty easy. All right, next one's as you go the reverse. It says write them in logarithmic form. So log, my base is 9, my number is 729, it equals the exponent 3. Log, the base is 5, the number is this fraction, 1/25, equals the exponent -3. Log, the base is 2, the number is 16, the exponent is 4. All right, so now on the last ones here, let's see how many, oh, we just have 3 of them. It says use the change of base rules to solve the following logarithms. So all you're doing is going log of 150 divided by log of 7. So log of 150 divided by log of 7. 2.575. So on the next one, log of 400 divided by log of 3. Log of 400 divided by log of 3. We get 5.454. All right, last one. We got 2 of them to do. Log of 729 over log of 3 plus log of 512 over log of 2. So we can actually do them all at once. We can actually go log of 729 divided by log of 3 plus log of 512 divided by log of 2. All right, and look at that. It turns out to be a nice whole number. That's actually kind of cool, 15. All right, that ends the review. Keep on plugging away on your take-home tests. We'll be giving you some time over the next day or two to get that done and sent in to me. If you have any questions, shoot me an email.